Observational study or experiment? Today, we are going to talk about what is what and how you can recognize each of them. So we're going to start by talking about anecdotal evidence, which is generally frowned upon when trying to make a conclusion. Okay, so anecdotal evidence is just a single or maybe a small number of results. They're often unusual cases that are not representative of the population, and usually these are just stories, okay? Like my aunt the other day, or oh, my grandma tried that medicine and she was sick for a week, or oh, I heard somewhere that that this thing isn't safe. Okay, these are all examples of anecdotal evidence. We can maybe give a little sad face because these are not great ways. Okay, not great for scientific conclusions. Okay, and again, a lot of these are like stories, or you know, I heard from so and so. Or my aunt, my uncle, etc. Okay? Now, sometimes anecdotal evidence is something, but in general, observational studies and randomized experiments are a much better way of getting scientific conclusions. Okay? So those are really what we're going to talk about more, and specifically, I'm going to spoil it for you guys. I'm going to spoil it for you. Randomized experiments, that's a smiley face. Observational studies is kind of both. Here, we'll give it a meh face. All right. So in an observational study, researchers are going to gather data, but they don't interact with the subjects. It's very noticeably lacking something called a control, which I'm jumping the gun all over the place today. Okay, please forgive me. Okay, so they're just recording or gathering data. And this can be retrospective, right? Gathering data on something in the past. Or it can be prospective, okay? Or actually involved, all right? A lot of times involved in what's going on. Okay? And again, so these can be a lot of things. Maybe we're doing some research and we're looking at this study in the past, or we're doing some research. We have data in the past and we're kind of, you know, working with that data and getting more information about that data. Or maybe we are actually just observing some people and seeing what happens. All right. But the true smiley face, the true gold standard for a lot of things is randomized experiments, okay? Because these are controlled environments. They're randomized as well. And researchers are going to assign treatments to groups of subjects and measure a response variable. Okay, so the main thing right here is a control, okay? Control has to do with, it's like a baseline, okay? A lot of times there is a control group, okay? And it's just essentially something to compare about. So if we don't have a control, right? If we're just observing people, then we don't know whether there are like these hidden factors or something. If I just look at a group of 20 people and say, okay, take this sugar pill and tell me if you feel better. And then if they all feel like a bunch of them feel better, well, maybe it had nothing to do with the sugar pill. We don't know. There's nothing to compare it against. So we have to give it to some people and not give it to other people. And that is the control group, which we're going to talk more about later. Okay, so that's very, very important. Randomization, also very, very important. And again, we'll talk more about these topics later. So let's do a little example, a little practice. Match the description with the proper term. So the first one, a group of disabled women aged 65 and older were tracked for several years, ending in 2010. Those who had a vitamin B12 deficiency were found to be twice as likely to suffer severe depression as those who did not. Okay, so as soon as like, this is kind of a key phrase here. They were tracked. We looked. We were watching them, and it was going on from several years, and we're not comparing it. Or we are comparing it, right? Those who had a vitamin B12 deficiency were found, no, we're just looking at the data, right? We're looking at who had a vitamin B12 deficiency, and we're looking at who suffered severe depression. Okay, so that's not a control. There's nothing being applied. There's no treatment. That's a kind of a big thing to also look at. Control and also response variable or treatment. These are the big things to look at for randomized experiment. So this doesn't have either of these. So this is an observational study. And the question is just, is it retrospective or is it prospective? Okay. So it kind of depends on the, if it ends in 2010, this is not going on anymore. This is in the past. This is retrospective. The next one. Researchers want to investigate whether taking aspirin regularly reduces the risk of a heart attack. 400 people who identify as men are divided randomly into two groups. One group is going to take aspirin, and the other group is a placebo. This right here. This is the control group. If we're curious about how something is effective or not effective as a treatment, we have to compare people who get the treatment with a very similar and randomized group of people who do not get the treatment. All right, and at the end of the study, researchers are counting the number of men in each group who have heart attacks. All right, so this right here, this is an experiment. It has a control. It has a treatment. So this is technically the control group, is what's underlined. Control group and treatment, those are the big things to look at for experiments. Third one, researchers who examined health records of thousands of males found that men who died of myocardial infarction, aka heart attack, tended to be shorter than men who did not die of a heart attack. Okay, so they're examining health records. It sounds like this is happening nowadays. This is happening currently. So we're going to say that's a prospective observational study. It's actually kind of hard to see which arrow is going, which arrow is going to where. Here, we'll draw another arrow. That makes it worse. It's okay. There's no matching in this class. You're never going to see matching again. I'm terrible at matching. And the last one is part D. A doctor worked with two patients and their depression was cured with vitamin B12 injections. Two patients from this one doctor. Probably not the best foundation for a scientific conclusion. That's anecdotal evidence. All right. So let's talk about some more concepts here. Specifically, in part C above, so part C, right, that was this one. Whoa! I didn't have my, whoa, sorry, I just yelled at you. I didn't have my pen selected. In part C, this is the one it's asking about, examining the health records. Is it correct to conclude that shorter men are at higher risk of dying from a heart attack? No. Right? There might be a confounding variable is the word right here. Confounding variables occur when we don't have proper control groups, proper things to compare against, okay? So a compounding variable in general is going to be something that we're not accounting for, okay? Something we're not accounting for, or separating or measuring. And you have to be very, very careful with observational studies. Confounding variables are big in a lot of observational studies. Another thing that you may have heard or may have not heard is that correlation is not the same as causation. Okay, so for example, right, maybe Maybe there's something that's causing kind of both, right? So maybe like, depending on where the study is, maybe these men have like a poor diet. And if you have a poor diet, that can affect your height, and it can also affect the chance of you getting a heart attack. Okay. That's like one example right here. So be very, very careful whenever you're looking at a statistic, whenever you're looking at a study or something like that. Don't just see that these two things have something in common. Try to figure out and make sure, hey, is one actually causing the other? And an experiment with a control group is actually one of the great ways that we can do that. Okay, so our answer is that no, it's not correct to conclude this. In which of the above situations can we infer causation? Well, I kind of spoiled it a little bit, but the experiment one. Okay, the experiment, it really looks like I'm linking these two. I'm not very good at matching. All right, watch this. This is 1. This is 4. This is 3. And this is 2. We did it. All right. So this is the situation where we can actually infer causation, because we're taking into account the effect of the aspirin, right? We can assume that these two groups, right, they are divided into two groups. We can assume that these two groups are randomly selected and that the sample size is big enough, 400 people, that these groups are more or less the same. So if we're looking at these groups and assuming that they're more or less the same, the only real difference is that one's getting aspirin and one isn't. So we can actually draw meaningful conclusions with this experiment of what's going on. All right. The experiment for the reasons that I kind of mentioned earlier. Okay. And that's basically what we have right here. Let me know if you have any questions.